Hello. I've been asked to go through question 9 on exercise 10E on page 172. One of the questions I set for homework. So I thought I'd just explain it on a video. Okay, so this is question 9. Let's just read it through quickly. We've got a car of mass 900 kilograms. Pulls a trailer of mass 300 kilograms along a straight horizontal road using a light tow bar. So this is going to be two particles. We're going to model the car and the trailer both as particles and the tow bar as a light rod. The horizontal resistances to motion of the car and trailer have magnitude 20 and 100 newtons respectively. The engine of the car produces a constant horizontal driving force on the car of magnitude 1200 newtons. We've got to show that the acceleration of the car and the trailer is 0.75 meters per second and find the magnitude of the tension in the tow bar. I think those are fairly straightforward, those two. I'll go through those quickly. And it is part C, I think, that's causing the most problems, which we'll get to. So let's go and do part A and B and number 9 first of all. So here we have the car 900 kilograms and the trailer 300 kilograms and connected by the light rod. Now we put on the forces. We know that there's a force of 1200 newtons driving the car, so that is 1200. We know that there are resistances to motion of 200 on the car and 100 on the trailer. And then we've got the internal force, which is the tension in the tow bar, like that, which we'll call T. So we need to find the acceleration A and the tension. So this is how to set this out. I mean, some of you, most of you have done this correctly, but very few of you have set it out in the way you should do. And the way you should do it is this: when you've got two particles connected which are moving in the same direction like this, then you can consider it as one system, or you can consider the two particles separately. If we want to find the acceleration in this case, we can consider as one system. So I would write whole system here, because that's what we're considering. And we're going to use Newton's second law of motion, which means, and we always write this, which means resolving. When we're using Newton's second law as a vector law, we have to use it in a direction. So we're doing it in the horizontal, in the direction of the acceleration. So we have, for the whole system, we have 1200 minus 200 minus 100. The t's cancel because they are internal. We've got plus t minus t, cancels out, it's not there. Equals m, which is the total m, which is 1200a, which is what we're trying to find. So we have 900 equals 1200a, and a is 900 over 1200, or 0.75 meters per second, so that's that one. And then to find the tension, well, we can consider either the trailer or the car. Let's go for the trailer. Again, we are going to resolve that way. And for the trailer, we have T minus 100 equals M, mass of the trailer is 300, times the acceleration, which we now know is 0.75. That gives us T equals 100 plus 225, so that's 325 newtons. So that is A, this is A, and this is B. So, returning to the question then, we have the car is moving along the road when the driver sees a set of traffic lights have turned red. He reduces the force produced by the engine to 0 and applies to the brakes. The brakes produce a force on the car of magnitude F, and the car and trailer decelerate. The resistances to motion are unchanged, and the magnitude of the thrust in the tow bar is 100 newtons. Find F. Now, the situation has now changed. So the thing is, you have to draw another diagram. This situation here with the forces as I've drawn them has changed. It's not the same. So what we will do is draw another diagram. So we've still got the car and the trailer and the tow bar, but this time we have a braking force. Now the braking force on the car, or let's put in the 900 and 300 there. Let's change the better. The braking force is a force which goes the opposite direction to the motion. The motion is still in that way, or we're moving that way. Well, let's put the acceleration as a positive in that direction. This is a new A, let's call it A dash. But the force is acting that way. The car is moving to the right, but the force is acting in the other direction in order to brake it. We've still got the two resistant forces of 200 and 100. And in the tow bar we have a thrust. Now a thrust is the force which is the opposite force to the tension. So instead of the tension like pulling the trailer, it is now pushing the trailer. So a thrust goes the other way, and in fact it's not T, because we know the value of the thrust, we know it's 100. So we've got 100 on both there. So we're looking to find F. We need the A dash, so we can consider the trailer. We have all the forces on the trailer, so we should find the acceleration that way. So we would say for the trailer, this is how we set it out. The trailer is what we are applying Newton's law to. So right trailer. What direction? If always pick the direction of motion. It's moving to the right. Even though it's slowing down, it's still moving to the right. So what do we have? We have minus 100, minus another 100. The first one is the resistance, the second one is the thrust, equals mass times A dashed. And so we have 200 equals 300, A dash minus 200 is 300, A dashed. And so A dashed is minus 2/3. Negative because it is slowing down. Which means the acceleration is acting in the opposite direction to the motion. Okay, so now we want to find F. Well, then we can consider the car. Or we could consider the whole system, in fact. The car, we have minus F. So again, resolving in that direction. Minus F, let's write it here. Minus F. Now we've got plus 100 for the here for the thrust on the car. Minus 200 for the resistance equals mass, which is 900, times the acceleration minus 2/3. You see, you have a different acceleration than before in parts A and B. So now we have an equation. We can find F. F, if we rearrange it, F equals minus 100 here, and we're pulling the other one, this on the other side, which gives us, that's minus 2/3 of 900 is minus 600. On this side is plus 600. So F is 500 newtons. Okay, and that is how we do question 9 in exercise 10E.